6.2 Trigonometric integrals and substitutions. Problem number 3 says evaluate the definite integral, the integral from 0 to pi divided by 2 of sine to the power of 5x times cosine to the power of 10x dx. Well, observe that sine to the power of 5x, 5 is an odd number, and so sine is to an odd power. And so we should save sine of x dx for du. Well, then if we did that, we would have to rewrite the integral. So the integral from pi divided by 2, the integral from 0 to pi divided by 2 of sine to the power of 4x times cosine to the power of 10x times sine of x dx. And this is our du. And so what we should do is we should figure out how can we rewrite this. So I know the antiderivative of cosine is negative sine, and so we should convert everything into cosines. So I know sine to the power of 4 of x is the same as sine squared x squared times cosine to the power of 10 of x times sine of x dx. And so now we can use a trig identity to rewrite sine squared of x in terms of cosine. So this is the same as one minus cosine squared of x squared, and then times cosine to the 10th power of x times sine of x dx. And so now we square this. So this would end up becoming 1 minus 2 cosine squared x plus cosine to the 4th power of x. And all of this is still multiplied by cosine to the 10th power of x. And we bring along our du. And now we can let u equal cosine of x. Then du is equal to negative sine x dx, or negative du is equal to sine x dx. Well, we would also want to break this down, so we can multiply this cosine to the 10th power x into all three of these terms. And we would have the integral from 0 to pi over 2 of cosine to the 10th power of x minus 2 cosine to the 6th power, or 10 plus 2 is 12. So this should be the 12th power of x. And then 10 plus 4 is 14, so plus cosine to the 14th power of x times sine of x dx. And now we can use our u substitution. So if we let u equal cosine of x, we have to substitute a negative du. So this would become a negative integral 0 to pi over 2 of u to the 10th power minus 2u to the 12th power plus u to the 14th power. And we're integrating with respect to u. And so now we can say that this is like negative 1 over 11 u to the 11th power plus 2/13 u to the 13th power plus or minus u to the 15th divided by 15, or this is similar to one of these scenarios as well. I just rewrote it so I could put this u to the power of 13 on top of this fraction as well. Well, now let's plug in our original function so that we can plug in our original limits. So this is negative 1 over 11 cosine to the 11th power of x plus 2 over 13 cosine to the 13th power of x minus cosine to the 15th power of x divided by 15. And now we would plug in our points. And so we know that the lower limit is 0 and the upper limit is pi divided by 2. And so when we plug in a pi divided by 2, cosine of pi divided by 2 is just 0. And so all of these terms would become 0. And so we'd have 0 minus, and now cosine of 0 is 1. And so all of these terms would be existent. And so we would have minus negative 1 over 11 plus 2 over 13 minus 1 over 15, which this would just end up becoming 1 over 11 minus 2 over 13 plus 1 over 15.